Hello. So today we are going to study a problem on photoelectric effect. So in a photoelectric experiment, both sodium, which is having work function 2.3 electron volt, and tungsten having work function 4.5 electron volt metals were illuminated by an ultraviolet light of same wavelength. If the stopping potential for tungsten is measured to be 1.8 volt, the value of the stopping potential for sodium will be. So we have to calculate the stopping potential for sodium. This question was asked in JAM Physics 2016. Now we know that EVS, it is equals to h nu minus W. H nu, it is the energy of photon. W, it is work function. So work function, basically it is the amount of energy which is required to eject the electron out of the metal surface. Frequency of the incident photon minus the amount of energy required to eject the electron out of the metal surface, that is equals to EVS. Okay, now here what is given is we have two metals, sodium and tungsten. So suppose let stopping potential for tungsten, we assume that it is not for tungsten, for sodium, suppose it is Vs. Now energy of photon hc by lambda, energy of photon E, it is equals to h nu, or we can write it as hc upon lambda. So energy of the photon hc upon lambda, it is equals to work function of sodium is given 2.3 electron volt plus stopping potential EVS. So E into stopping potential, so EVS, energy. Now here I have just reframed this equation. H nu equals to EVS plus W. I am writing this way. Or H nu ke jagah pe I have written HC upon lambda. So this equation is reframed this way. So HC upon lambda equals to 2.3 electron volt plus EVS. This is equals to nothing but, because both the metals were illuminated by ultraviolet light of same wavelength, so energy will be same. This is nothing but equals to work function of tungsten. It is given to be 4.5 electron volt plus what is given is stopping potential for tungsten. So E multiplied by stopping potential for tungsten, it is 1.8 volts. So what I am getting is 2.3 electron volt plus EVS equals to 4.5 electron volt plus 1.E EV. So EVS equals to 4.5 plus 1.8. I will shift this 2.3 over this side, and when I will calculate, I will get 4 electron volt. Now E and E will get cancelled. What I'm getting is EVS equals to 4.5 plus 1.8, and I shifted this 2.3 over here, so minus 2.3. So when I calculate, I will get EVS equals to 4 electron volt. E will get cancelled on both the sides, so Vs equals to 4 volt. So this is the stopping potential for sodium. This is the answer. Okay, now let's start new numerical. X-rays of wavelength lambda equals to 0.612 into 10 raised to minus 10 meter are scattered by free electrons, Compton collision. First, calculate the wavelength of the scattered radiation at an angle of 90 degree with the direction of incidence. Second, calculate the corresponding kinetic energy in joules imparted to the electron. This question was asked in JAM Geophysics 2007. In earlier lecture, we have done similar numerical. Okay, so here what we will do, we know that what is given is wavelength of X-rays. So wavelength of X-rays, it is given to be 0.612 into 10 raised to minus 10 meter. Or if we write in terms of angstrom, it is 0.612 angstrom unit. Now, you know the formula for Compton shift. Compton shift, it is given by delta lambda equals to h upon m0c 1 minus cos of phi. Now here in the numerical, what is the value of phi? Phi is given to be 90 degree. So phi is 90 degree. So delta lambda equals to h upon m0c 1 minus cos of 90. Cos 90 is 0. So here we will get h upon m0c. 1 minus 0, it is 0. So last time also I asked you to remember this value h upon m0c. So last time we have seen that 2h upon m0c, it comes out to be 0.048 angstrom. H upon m0c, therefore it will be just half of this, 0.024 angstrom. So in most of the numericals, you need this value, either h upon m0c, 2h upon m0c. So remember just one value. Okay. So h upon m0c, it will be 0.024 angstrom. So no need to do these calculations every time. Once you will start doing these numericals, automatically you will remember this value. Now, what we have to find out is wavelength of the scattered radiation. That means we have to find out lambda dash. So wavelength of scattered radiation, that is lambda dash, it is equals to lambda plus delta lambda, because we know that delta lambda equals to lambda dash minus lambda. So lambda dash, it is equals to lambda plus delta lambda. Lambda, we know it is given in the numerical 0.612 into 10 raised to minus 10 meter, and I converted it in angstrom. So it is 0.612 angstrom plus shift. Shift is 0.024 angstrom. So if I calculate this, it will come out to be 0.636 angstrom unit. So this is the value of wavelength of scattered radiation. Now there is second part in the numerical where we have to calculate the corresponding kinetic energy in joules imparted to the electron. So let us calculate the B part. Now kinetic energy of electron, it is given by hc by lambda minus hc upon lambda dash. I can take hc common, 1 by lambda minus 1 upon lambda dash. So this is energy of the photon. This is energy of the scattered photon. So when we incident a photon, then some of its energy, it is used by the scattered photon, and rest of the energy, it is used by electron as its kinetic energy. That is how this formula, hc by lambda minus hc upon lambda dash. So we have hc 1 by lambda minus 1 upon lambda dash. Now substitute these values. H is 6.64 into 10 raised to minus 34. C is 3 into 10 raised to 8. 1 by lambda. Lambda is 4. What is the value of lambda? Lambda is 0.612 minus value of lambda dash is 0.63626. Okay. So if you will substitute all this is multiplied by both of this is multiplied by 10 raised to minus 10, because we have to convert in meters. So if you will calculate this value, you will get answer. So find out that answer and check how much you are getting. This value you will get in joules. So in electron volt, I'll tell you this value, 772.55 electron volt. So whatever value you are going to get in joules only, and we are supposed to find out in joules only. I'm telling you this value so that you can check whether you are getting same value. And conversion is 1 electron volt equals to 1.6 into 10 raised to minus 19 joules. So this is homework for you, and if you have any difficulty, just let me know. Thank you.